So here we go. First thing you need to know about moments is the formula itself. So first thing, moments equal force times perpendicular distance. It's very important to understand that it's perpendicular distance, not just distance in general, because a lot of people, and you'll see, the force isn't always going to be perpendicular. Sometimes it can be parallel, so it's important that they are perpendicular. Going from there, basically what you're going to see is that a rotation around an axis. So let's say we have a wrench around a bolt, right? So I'm going to zoom in real quick here just so you guys can see what we're doing. Let it focus. There we go. So this one right here, the first one, you guys cut these. Should look something like this. Okay. So basically the first one here, we have a force that is rotating around an axis. If the moment itself, not the force, it's important to understand that the moment is negative when the force is rotating in a clockwise manner. So negative if they are going in a clockwise manner. So clockwise. Okay? Counterclockwise, CCW, is going to be obviously looking the opposite, and that is going to make your moment positive. So in this case, if I have a pivot, or what I told you, a fulcrum, aka what? Pin in this case, right? If I have a fulcrum right here, and this force is acting around, it's going counterclockwise or clockwise. So immediately you're going to know that my moment is going to be a negative moment, right? Is the distance that they provide perpendicular to the force? It is. So all I have to do in this case is solve for the moment. Moment equals force times distance. So the force in this case is 20 times, and these are in pounds, times 9 inches. Multiply those together, and you get 180, correct? Okay? And these are inch pounds. In pounds. Now, the problem that is, it's got to be negative, because it is going as a negative clockwise motion. Okay? Any questions on that? Go ahead. Because it's provided right here. Oh, okay. Here we go. Are we good on that one? Yes. It's inch pounds. Yeah. Yeah, so if you look at the PowerPoint, it goes through what it should look like, but it's literally just, it's pounds per foot, or like this. It's what it should look like. Inch per pounds in this one, because it's not foot per pounds, but I'm saying, yeah, you can do it that way too. It doesn't matter. Just inch, no squares. Okay, so same thing down here. The exact same thing. Now we have foot, now we have pounds, same difference, but now it's going to be pounds per foot, or foot pounds in this case. Same difference. This is going down, so that is going clockwise, creates my moment to be negative. My moment is force is 20 times 1 foot, right? What is imperative in this case, though, is that you have to understand, okay? It needs to be in foot or inches. Let's talk about that first. Does it need to be in feet, or does it need to be inches? So is there such thing as an inch per pound, I should say? Is there something by a foot by pound? It's foot pounds, right? Or pounds foot is what it's called, lb-feet. So in this case, what you're going to see is what they do, and I'm walking through the PowerPoint while I'm doing this, but if you look at the PowerPoint, they go through and say 1 foot is negative 20, and they keep going through it. They're both perfectly fine. It doesn't matter. You don't have to convert anything. A lot of people freak out and they think they need to. There's no need to. So in this case, it's 20 times 1 foot, right? The only difference is obviously this is 20, but what's wrong about that? Correct, negative, because it is in a negative rotation. Next. This one is a little tricky. Think of the pivot point still here, and I'm rotating this around. Is this going to be going clockwise? And if I keep this here and rotate it and force the let's say this way, if I force this to go around, is it going clockwise or counterclockwise? Still going clockwise, right? So it's still it would literally look like be like this connected. As I'm pushing this force, it's going to rotate like this. No, this is what I'm trying to get at, but you're literally talking over me. I'm not done yet. So is 1 inch or 1 foot parallel or perpendicular to the force? So we can't, this is literally just there to trick you. It has nothing to do with it, okay? All you need to focus on is exactly what they were saying, the perpendicular distance to the force itself. So the moment is now 20, negative 20 I'll put just because it's already done, right? Times 3, which gives us negative 60 inch-pounds. This is literally to trick you, okay? Literally to trick you. Move up. This one is another one to trick you. Does this mean anything? No, because the force is parallel with the distance here too. The other little trick that you need to understand is that if I have a pivot point here, it is the distance to the force. So we have to add these together, 8 and 10, obviously, to give us 18. So we are going to take the force, which is a negative because it is going clockwise, multiply that by 18 to get our moment, and in this case, inches, still pounds. 20 times 18 gives us 360. Negative 360 to be exact. Go ahead. Question. Okay. Next, if you keep going through the slides, again, this is just another example. So I have the same concept here, but now they go the opposite way, right? So if you look at the rotation, here is my pivot point, here is my axle, so to speak. My radius now is in centimeters, and this is where we have to understand, if you look at the chart that they give you, I'm going to go back and forth here, but it looks like this. Oops. So I'm going to make media source. Oops. Here we go. So if you go back and look at this chart here, I'm going to show you guys on the video, but I'm going to also show you here. If you go back to what it shows on the video or on the PowerPoint, you need to make sure that it's in one of these systems, right? So if we're going to use newtons and meters, and they give you centimeters, it's important to convert, okay? So they give you centimeters. Pretty self-explanatory, obviously, in this case, but I wanted to make sure that we're clear that it's either in foot per pounds, inches is fine for the first one, and then eventually newtons per meter, okay? Don't put it newtons per centimeter. We need SI or English. Just stay consistent with whatever you guys are going to do. So if I keep going, and again, this all is shown in the PowerPoint, but they go through and this is later, they go through and they do the radius in centimeters, and then they convert. So it says 50 centimeters, which is the same as saying 0.5. We move the decimal place. 0.512 is in meters. Now we have our meters, we have our newtons, which is given to us, right? So I'm going to show you that. So if we have, in this case, switching. If we have, in this case, now we have our meters, now we have our newtons. We can do the same calculations we've been doing, force times distance, and it is perpendicular, so we're good. 100 newtons times our 0.5 meters, which is, what's half of 100? Is your moment. Pretty self-explanatory, and that's what it shows you on the PowerPoint as well. Okay? Is it positive or negative? If you look at it very closely, it rotates like this, which is counterclockwise, which is positive. Those are pretty easy. The newer stuff that I'm sure you learned in